Good morning, students. So today we will start. In the last class we have started integrals and we discussed about that the integration is the inverse of differentiation, and we discussed some formulas. I have given you the formulas of different standard formulas for differentiation of different functions. So now today at first I am giving you the standard formula for integration. Okay, means these are all integrals, so directly you can apply these formulas. So the very first is integration of x to the power n dx. Okay, when any variable, and here we integrate with respect to x to the power n dx, the formula is x to the power n plus 1 divided by n plus 1. But in differentiation, what is the formula for x to the power n? It is nx to the power n minus 1. Here your n never be equal to minus 1, because if it will be minus 1, then the denominator is 0, which is not possible. Now integration of dx, only dx when you integrate, means if you have any constant here, okay, suppose 1 to any number, any constant a, b, c, whatever, any constant, then dx, then the integration of that one is x. Means you keep in mind the integration of dx is always x. Now, integration of cos x dx is sin x plus c, and here you see differentiation of sin x is cos x and integration of cos x is sin x. They are inverse. Okay. Similarly, integration of sin x is minus cos x and differentiation of cos x is minus sin x. Okay, so these formulas are inverse of each other. So here I have given so many formulas of integration. These are the standard formulas which you have to remember very carefully. Okay, and this is the inverse function. We know differentiation of sin inverse x is 1 by root over 1 minus x square, and here integration of 1 by root over 1 minus x square is sin inverse x. And here you see with each and every formula we have a plus c, means while doing integration it is necessary to write the constant of integration with the integral value, right? These are some, and next more formulas are there which you note down these formulas in your copy and try to remember each and every formula very carefully. It should be, means you have to memorize this formula, right? Here see, integration of 1 by x dx is log x plus c, and we know differentiation of log x is 1 by x, and integration of e to the power x exponential function is the same as it is, and differentiation of exponential function is again the same function. Okay, so these are the standard formulas which we require while doing the problems of integrals. Now we move to geometrical interpretation of integration. Okay, geometrical interpretation of integration. Indefinite integral. So first we study indefinite integral. Geometrical interpretation of indefinite, means which do not have any limit, indefinite integral. So geometrically how we interpret this integral. Okay. Suppose we have a function f of x equals to twice x. Okay, we have a function f of x equals to twice x. Then what will be the integration of f of x dx? Means integrating this function with respect to x. Okay, so see how we integrate it. 2 is constant, so we take it out, integration of x dx. Now see which formula we apply. X dx, we have studied the formula for x to the power n. So here your n is 1, so x to the power n, integration of x to the power n dx is x to the power n plus 1 divided by n plus 1 plus c. So from here we get 2 into x 1 plus 1 by 1 plus 1 plus c. So we get here this 2 and this 2 get cancelled, so ultimately we get x square plus c. This is the integral value of the given function. But here you see c is a constant. Okay, so in place of c we can use different values, means we may put 1, 2, 3, any values for c. So for different values of c we get, because c is an arbitrary constant, so for different values of c you get different curves. Okay, so we get, our equation becomes y equals to fx equals to y, so fx is x square plus c. Now since c is arbitrary constants, you get different curves, means you get ultimately a family of integrals. Okay, it represents a family of integrals. Okay, so when we apply different values to c we get different members. Okay, suppose we apply c equals to 0, then we get y equals to x square if you put c equals to 0. Okay, and this is the equation of a parabola. You studied in your conic section, we have 4 standard equation of parabolas, and this is another. Y equals to x square is the equation of parabola having its vertex on the origin. Okay, its vertex will be at origin. Now if we take c equals to 1, okay, c equals to 1 means we obtain the, it is again an equation of parabola, but it shifts 1 unit along the y-axis in the positive direction. Okay, and if we take c equals to minus 1, means suppose you take c equals to 1, then your curve become y equals to x square plus 1, and if you take c equals to minus 1, y equals to x square minus 1. This is in the, this is at origin, this parabola is at origin, which is vertex is at origin, but here it is 1 unit in the above direction of origin, that is in the positive direction of y-axis. X square minus 1, it is in the negative side of the y-axis. Okay, so in this way we get different value, different curves, so it called a family of curves we get. So it will be like the, when we plot here in the graph, so somehow we get the equation like this. The y equals to x square means your parabola has the vertex at origin. Okay, now when c equals to 1, then your parabola is 1 unit in the positive direction. When c equals to minus 1, the parabola is 1 unit in the negative direction, means this is for the curve y equals to x square minus 1, this is for y equals to x square plus 1, this is for y equals to x square. So when we use different values of c, we get different curves. So ultimately we get a family of curves here. Now let us consider the intersection of all these parabolas by a line x equals to a. Suppose we draw a line here. This is the line, and the equation of this line is x equals to a. It intersects each and every parabola. Okay, and we take a as a positive. When also if you take the value of a less than, means x equals to some negative value, then also you get a line here which intersect each and every parabola. Okay, then when you find dy by dx for each and every parabola, means when you find the tangent, okay, for each and every curve, then you will get it is equals to twice a, okay, and which indicates the tangents of these parabolas are parallel. Means this is the tangent for this parabola, this is the tangent for this one, and the tangent for this one is, these three are parallel to each other, right? So this is the geometrical interpretation of a indefinite integral, okay. So we have here the function as f of x, and integration of f of x dx equals to capital F of x plus c, and it represents a family of curves here for different values of c, and this is the geometrical interpretation of the indefinite integral, okay. Now we move to the properties of indefinite integral. Some properties of indefinite integral. The very first property as differentiation and integration are inverses of each other. Differentiation and integration are inverses of each other. Means if you have d dx of f of x equals to f dash of x, it means integral of f dash of x dx equals to f of x plus c, okay. So these two are inverses of each other. The second property is integration of f of x plus g of x dx is equal to integration of f of x dx plus integration of g of x dx. Means if f and g are two functions and they are in, we have the sum of these two functions, means you have to find the integration of this function, then separately you can find out the integration of both the functions. The result is same. The third property, for any real number k, for any real number k, integration of k f of x dx is equal to k integration of f of x dx. Means if k is any real number, it is constant, you can take it out, k outside the integration sign, okay. And now property third and second can be generalized to n functions, okay, to finite number of functions. Suppose in property second you have two functions, sum of two functions, there may be n functions, right, many functions. So you can also use that property for n functions. Here also if you have k multiplied with, means suppose k1 k2 k3, in this way you have real numbers with different functions, then you can separate it out, means you can use this property there also. Okay. Now let us do an example. You have to write the antiderivative for a function, means antiderivative means integration. You have to do the integration. Okay, so find antiderivative of cos 2x. You have to find the antiderivative, means you have to find the integral value of this function. Okay, so the way, means from base, if we start from basics, so we know what is the differentiation of, when you remember the formulas you can directly use those formulas, but I am explaining you what is the differentiation of sine 2x. Differentiation of sine 2x is, we know differentiation of sine x is cos x, so it is theta. Here theta is 2x. And when we apply the chain rule here, we have to differentiate the theta also because it is a function of x. So ultimately we get 2 cos 2x is the value for integration of differentiation of sine 2x. Now this implies cos 2x is equal to 1 by 2 differentiation of sine 2x. Okay, cos 2x equals to half differentiation of sine 2x, and this can be written as differentiation of half sine 2x is equal to cos 2x. Okay, so antiderivative, from here we write antiderivative of cos 2x is half sine 2x. Why we have write this? Because we studied differentiation and integration are inverse of each other. Now if a differentiation of some function is this, it means integration of this function is this, right? যদি এটা ফাংশনৰ ডিফাৰেন্সিয়েট কৰি তুমি যিটো ভ্যালু পোৱা ৰিজাল্টটো, সেই ৰিজাল্টক ইন্টিগ্ৰেট কৰিলে তুমি কি ভ্যালু পাবা? the given function. Okay, that is why we say differentiation and integration are inverses of each other. So ইয়াত আমি ডিফাৰেন্সিয়েশন দিয়ে আনসারটো ওলালো যে আমি ডিফারেন্সিয়েট, we know that differentiation of sine 2x is 2 cos 2x. From here we write cos 2x equals to 1 by 2 differentiation of sine 2x. We take inside 1 by 2, so we get the differentiation of half sine 2x. And half sine 2x, if differentiation of half sine 2x is cos twice x, it means the integration of antiderivative means integration. Integration of cos 2x is half sine 2x. This is one way. Or if you remember the formula directly, what is the integration of cos x dx? Integration of cos x dx is minus sin x plus c, right? So what we can do here, this is the standard, but in our question we have integration of cos 2x dx, means you have to find the antiderivative of this. So first we know cos 2x means minus sin 2x, but here also you have to apply the chain rule. But in differentiation, when you apply the chain rule, when you differentiate 2x, you get 2 and it 2 comes here. But here when you here what you have to do, you have to apply the direct formula result here. But when you go to the chain rule, here in chain rule you have to differentiate. Suppose আমি ইয়াত cos 2x or minus sin 2x পালো, কিন্তু 2x তো x or function, এইটোক তুমি ডিফারেন্সিয়েট কৰিব লাগিব। Okay, that is the chain rule. So ইয়াত কিন্তু ডিফারেন্সিয়েট কৰিলে কি আহিব, 1 by 2 to এনেকৈ আহিব, 2 to ডিফারেন্সিয়েশনত ডিনমিনেটৰত আহিব, ডিভাইড হৈ যায় ইণ্টিগ্ৰেশ্যনত যেতিয়া আমি কনষ্টেণ্টটো মানে চেইন ৰুল এপ্লাই কৰি কিনে যিটো কনষ্টেণ্ট পাওঁ দেট কামছ ইন ডিনমিনেটৰ চ' উই গেট মাইনাছ হাফ sin 2x plus c. Okay, so here I have done one mistake. This is positive, right? So ai bhul hoy jodi formula bhalke monot na thake confusion hoy gole eto bhul hoy jay, so it is positive. So half sin 2x plus c. মই কেনেকৈ গম পালোঁ ভুল হোৱাটো কাৰণ ইয়াত মই এইটো হাফ sin 2x পাইছোঁ. so this is the another method, right? means পিছলৈকে তুমি এনেকৈ ডাইৰেক্টলি ইণ্টিগ্ৰেশ্যন কৰিব লাগিব. সো মনত থাকিল যে ইয়াতে যেতিয়া চেইন ৰুল এপ্লাই কৰিম তুমি চেইন ৰুলৰ ডিফাৰেঞ্চিয়েশ্যনে কৰিব লাগিব. বাট ফাৰ্ষ্ট তুমি ইয়াত কি এপ্লাই কৰিলা ইণ্টিগ্ৰেশ্যন অফ cos x ইজ sin 2x. বাট আগেইন when you go inside means যেতিয়া আৰু নেক্সট থিটা কৰিব গ'লা দেন থিটা ইউ হেভ টু ডিফাৰেঞ্চিয়েট. বাট সেই ডিফাৰেঞ্চিয়েশ্যনৰ ভেলুটো ক'ত আহিব? ডিনমিনেটৰত আহিব. অ'কে, let's do one more question. So ito আমি directly কৰো. Find the antiderivative of 3x square plus 4x cube. 3x square plus 4x cube. Okay, itur antiderivative ওলাব লাগে মানে ইন্টিগ্ৰেশ্যন কৰি. এতিয়া চোৱা ইয়াত আমি প্ৰপাৰ্টি কেনেকৈ ইউজ কৰিম. আমি প্ৰপাৰ্টিত কি পঢ়িছিলোঁ যে if a function fx plus gx over dx then it can be written as integration of fx plus integration of gx. This is the second property. Now k into f of x, here your k is 3, here your k is 4, so you take 3 outside, integration of x square dx plus 4 integration of x square. So here we use the property second, here we use the property third. Now we know what is the formula for x to the power n. This is x n plus 1 by n plus 1 plus 4 x to the power 3 plus 1 by 3 plus 1 plus c. ইয়াত তোমালোকে কনষ্টেণ্ট দুটা ফাংচন আছে জাষ্ট ইয়াতে c1 c2 কৰিও লিখিব পাৰা বা কম্বাইনলি দুটাৰ এটা কনষ্টেণ্টটো লিখিব পাৰা আৰ্বিট্ৰেৰী কনষ্টেণ্ট অফ ইণ্টিগ্ৰেশ্যনটো. so it becomes x cube plus x to the power 4 plus c. so this is the antiderivative of the given function. Okay, so in the next class we will proceed further. Thank you.